Okay, good morning all of you. In today's session of acids, bases and salts, we are going to have a look at how acids are prepared. Now, acids are prepared by four methods. There are broadly speaking four methods to prepare acids. The first method is suppose you want to prepare a binary acid. Binary acid is an acid in which exactly two elements are present. So suppose you want to prepare a binary acid. So suppose you want to prepare HCl. So H2 plus Cl2 will be 2HCl, H2 plus Br2 will be 2HBr, H2 plus sulfur will be H2S. So this is the method we can say. The method is to prepare a binary acid. Binary acid means with two elements. The second method is that if you put water on a non-metallic or acidic oxide, okay, if you make water react with a non-metallic or acidic oxide, so suppose water with SO3, water with SO2, water with CO2, water with P2O5, water with N2O5 and water with NO2. So these are all acidic oxides. So if you make water react with an acidic oxide, then also you will get an acid. So SO3 plus H2O is H2SO4, SO2 plus H2O is H2SO3, CO2 plus H2O is H2CO3, P2O5 plus 3H2O is 2H3PO4, N2O5 plus H2O is 2HNO3, and 2NO2 plus H2O is HNO2 plus HNO3. So these acids which you have got, these are all called oxyacids. Oxyacid is an acid, like see the previous one was binary acid. Binary acid will have two elements. Oxyacid will have hydrogen and oxygen and another one element will be there. Like here you will have hydrogen and another element, but in oxyacid you will have hydrogen. So you will have hydrogen, oxygen and another one element. So these are all oxyacids. Now there is a very interesting thing about this is written acidic oxides. So we'll talk about this in some other session, but oxides may be acidic or basic without having any hydrogen or OH minus. So SO3, SO2, CO2, P2O5, N2O5, NO2, they are acidic oxides but they don't have any hydrogen at all. Another thing is all acidic oxides you will find they are non-metal oxides. Like you are aware, sulfur, carbon, phosphorus, nitrogen, they are all non-metal, right? Generally, acidic oxides are non-metal oxides. Now, is it a rule? Always acidic oxides are non-metal oxide. Is it a rule? No. There are some oxides which are acidic, like Mn2O7. It is an acidic oxide. Okay, manganese oxide, Mn2O7. It is an acidic oxide. Okay, but it is not of a non-metal. So that is also likely. So these are all the acidic oxides with water and giving oxyacids. Now one very interesting thing is NO2. NO2, when you treat it with water, it is giving two acids. It is giving HNO2 and HNO3. It is giving two acids. By the way, HNO2 is a weak acid, HNO3 is a strong acid. That's a separate issue. But it is giving two acids. So NO2 is an exceptional non-metallic oxide or exceptional acidic oxide which gives two acids when treated with water. So you can make a note of this. This is an exception. Okay. Then we come to number 3. In number 3, what happens is that you can use a non-metal like sulfur or phosphorus with concentrated nitric acid. Okay, a non-metal with concentrated nitric acid. Okay, non-metal with concentrated nitric acid, it will give you these products. Now, there is one important thing you have to remember, that concentrated nitric acid, it is an acid, it is obviously nitric acid, but concentrated nitric acid has got a property, it is also a good oxidizing agent. I have already told you what is the meaning of oxidation. So concentrated nitric acid is a very good oxidizing agent. So concentrated nitric acid will oxidize sulfur, to H2SO4 and it will oxidize phosphorus to H3PO4. So in the process you will get these two acids H2SO4 and H3PO4. So this is method number 3. So non-metal with concentrated nitric acid. Method number 4. If you take H2SO4 and treat it with NaCl NaNO3, then from this you will get HCl HNO3. Now there is a reason for this reaction to happen. Actually the substances like acids, they are categorized as volatile and non-volatile. I think all of you know, loosely you know what is volatile. If you leave it, it will start evaporating on its own. Anything that will, if you leave it and it evaporates on its own, it is called volatile. Now sulfuric acid H2SO4 is not volatile. So when you react substances like NaCl, NaNO3 with sulfuric acid, then you can get acid out of the reaction which is volatile. So H2SO4 is what? It is non-volatile. But HCl, HNO3, they are what? They are volatile. So this reaction allows you to start from non-volatile and prepare volatile acid. So this is reaction number 4. Okay. So these are the reactions for today. Okay, these are the reactions for today. Now I am giving you one homework. This point number 3, sulfur plus concentrated HNO3 and sulfur plus concentrated HNO3 and phosphorus plus HNO3. So I am giving you some homework based on this. So I am giving you one homework. Just like sulfur plus concentrated HNO3, phosphorus plus concentrated HNO3, you can have iodine plus concentrated HNO3 and carbon plus concentrated HNO3. I was telling you that if you take concentrated HNO3 with a non-metal, you will get oxidized product. So this can happen with iodine and carbon also. I have given you the reaction without balancing. Your homework is that you must write down these two reactions in your copy, balance them and submit the homework, right? So this is iodine plus concentrated HNO3, carbon plus concentrated HNO3. You must write down the reactions in your copy, balance it and send it as your homework. That's all for today. I'll end this session. Bye all of you.